Today, we shall be studying kinematics. So this is an aspect of dynamics which studies the motion of an object without regarding the force that causes the motion. Well, it's easier to study motion when we classify motion into horizontal motion and vertical motion. The horizontal motion, when we say horizontal motion, we're talking about rectilinear motion. So, a rectilinear motion is simply motion of an object in a straight line. Now, for horizontal motion, we are looking at, for instance, motion of a car, motion of an athlete running, motion of a kicked ball, anything moving horizontal in this manner is classified as horizontal motion. And so these are our equations for solving this motion now. V is equal to U plus AT. Most authors don't like adding X here. But as we progress along this study, you understand why we have X here. But we're adding this X to show that this velocity we're talking about is velocity for horizontal motion. So Vs is equal to Ux plus AT. Or simply say V equal to U plus AT. That's the first motion. The second equation is S is equal to Uxt plus half AT squared. And then third is S is equal to U plus V over 2 multiplied by T time. And then last one, I say V squared is equal to U squared plus 2AS. Understand that A stands for acceleration in meter per second square. Then V stands for final velocity in meter per seconds. U stands for initial velocity in meter per seconds. And S stands for distance covered in meter. T stands for time in seconds. Example 1, a car accelerates from rest. I want to say this now. Whenever an object starts from rest, it simply means initially it was not moving. Start from rest. We can easily say that initial velocity is equal to 0. Now understand, because I understand that the motion of a car is an horizontal motion, that's how I will solve it using these equations now. Next, a car accelerates from rest at 5 meters per second square. That's the acceleration, 5 meters per second square. Determine its speed after 10 seconds. If you have to find the speed, or you can say the velocity. Now, if we're given the U, obviously the other speed we should be looking for is the V. This is required. After 10 seconds, that should be talking about the time. T equal to 10 seconds. So we have our U, we have our V, looking for V, and then we are giving our A and T. What equation here has V that we can use? Obviously, if you look carefully, it will be the first one. Since I'm looking for V, and I'm giving my U, I am giving my A, and I'm giving my T. So let's go now. We have V of X is equal to U of X plus AT. Now, what's our U? That's 0 plus, what's our A? 5 multiplied by the time, 10. Eventually, this will become 50 meters per second. That's my velocity. That's that for this question. Example 2. A bus traveling at 60 km per hour accelerates uniformly at 5 meters per second square. Calculate its velocity after 2 minutes. So, solution. Now, let's bring out what we are given now. Our given. We have a bus traveling at 60 km per hour. That's the first speed. It's important to convert this to meter per seconds. If you have kilometer per hour, to convert to meter per seconds, all you just need to do is 60 multiply by 1000 and divide by 3600. And so this will give us 16.67 meter per seconds. Now the next thing we are giving here is a bus traveling at 60 km accelerates uniformly at, that's the acceleration, 5 meters per second square. Calculate the velocity after 2 minutes. That's the time, 2 minutes. The time should be in seconds, so multiply by 60. And that's 120 seconds. So right now we're looking for the velocity. That's V. That's the required. So I'm going to say V is equal to Ux plus AT. That's the equation to use because we have our U, yes, we have our A, we have our T, and we're looking for V. What's our U now? 16.67 plus our A, which is acceleration 5, multiplied by T, which is 120. So this will be 16.67 plus 600, and this will be 616.67 meter per seconds. Example 3, a car starts from rest. So we are given that the ux is 0 since it starts from rest. Understand, I'm using these equations of motion again because cars move in an horizontal manner. Now, and accelerate uniformly at the rate of 5 meters per second. Calculate the magnitude of the velocity after moving through 100 meters. That's the distance traveled, 100 meters. We're looking for the V. Well, we have our U, A, and S looking for V. Obviously, the only thing that can give us V here is this. Since we are giving this, and this, so we're going to say Vx squared is equal to U of x squared plus 2AS. So V of x squared is equal to U of x should be 0 squared plus 2 times our A, which is 5, times our S, which is 100. So this is Vx all squared is equal to 2 times 5, 10. 10 times 100, that will give us 1000 now. So we'll take square root of both sides. The square root of this, take square root of this. V of x will be equal to square root of 1000 will give us 31.62 meter per second. Okay, example 4 now. A uniformly retarded object comes to rest in 30 seconds after traveling a distance of 60 meters. Calculate the initial velocity of the object. Well, the first is to bring out the given. A uniformly retarded object. And so, comes to rest in 30 seconds. If an object comes to rest, it means that the final velocity is 0. Now, what I want you to take note in this motion we are treating is that it's a uniformly accelerated object or uniformly retarded object. So, these equations will still take care of it. Now, comes to rest in 30 seconds. If it comes to rest, the final velocity is 0, like I said. If it comes to rest, final velocity is 0. If it starts from rest, initial velocity is 0. So we have our time to be 30 seconds. After traveling a distance of 60 meters, that's our S, 60 meters. Okay, so we're looking for the initial velocity. That's the U. So what equation are we supposed to use to solve this equation? We're looking for U, and we have V, T, and S. V, T, and S. We're looking for U. This solves it. The rest should not be able to do it. So we'll say S is equal to Ux plus Vx all over 2, then times T. So S is given as 60 is equal to Us, the required, plus Vx 0 over 2 multiplied by time, which is 30. 2 here 1, 2 here is 15. We're going to have 60 being equal to 15 times Ux will give us 15 U of x. Divide here now by 15. Divide here by 15. Whether our Ux is equal to 4 meter per second. So U of x is equal to 4 meter per second. When brakes are applied to a moving car traveling at 60 km per hour. And so for this example 5 now, initial velocity is 60 km per hour. Now, I have to convert to meter per second. That will be 60 times 1000 divided by 36. So that's 16.67 meter per second. Okay? It decelerates at a uniform rate of 5 meter per second. So deceleration is negative acceleration. That's minus 5 meter per second square. Calculate the time taken to reach a velocity of 36 km per hour. That's the final velocity, V. 36 km per hour. This will be 36 times 1000 divided by 36. And that will give us 10 meter per second. So we have our U, A, and V. We are looking for the time taken. So we're using this. V is equal to U plus AT. Our V is giving us 10. Our U is giving us 16.67 plus our A is minus 5 times T. So this becomes 10 being equal to 16.67 minus 5T. So let me divide my board into 2 now. Bringing this 5T here will give us 5T, and then transfer this 10 to this side will give us 16.67 minus 10. So this got 5T being equal to 6.67. And then dividing both sides by 5. T becomes 1.3 again 3 seconds. So that's that about that. Example 6, which happens to be our last example. Starting from rest, a Formula 1 car accelerates uniformly at 4 meters per second. Well, since it starts from rest, our UX is 0. At 4 meters per second, that's the acceleration, 4 meters per second square. Now, what distance does it cover in the last 1 second? Okay, so for the last 1 second simply means from the 29th seconds to the 30th seconds. Is wrong. Starting from rest, a Formula 1 car accelerates uniformly at 4 meters per second square for 30 seconds. What distance does it cover in the last 1 second? Okay, this simply means that the last 1 second should occur between 29 to 30. So I should know the distance it has covered the 29 seconds and the distance that covered the 30th seconds. I will subtract the 2. And so where our initial velocity, since it's starting from rest, initial velocity will be 0. And the acceleration is 4 meters per second square. So at the 29 seconds now, that is T equal to 29. What distance did it cover? S is equal to UXT plus half AT squared. So we can say X at 29 is equal to the EU, which is 0, times the T, 29, plus half times A, which is 4 times T, 29 square. So this will give us 0 times 29, will give us 0. And so we would have 2 here 1, 2 here 2. So S at 29 will simply be 2 multiplied by 29 square, 1682 meters. Now, at the 30th seconds, that is T is 30 seconds, what will be the distance? X at 30. That will be the UXT. 0 is the U, initial velocity, times T, 30, plus half times 4 square, acceleration, 4, times 30 square. Well, let's continue here now. So this will give us gone x30 to be equal to half of 4, 2 here 1, 2 here 2. 30 square will give us 900. 900 times 2, 1800. So the distance at the 30 seconds will be S30 minus S29. And that will give us 1800 now, which is what we got for S30, minus 1682. So this will give us 118 meter. We have another method for this, another formula for this now. And that's giving us the x at the last 1 second will be equal to u plus at minus a over 2. And so where t is the 30th seconds now. So this will be u, that is 0, plus our acceleration 4 over time, which is 30, minus a, which is 4 over 2. So this is just 4 times 30 will give us 120, minus 4 over 2, that is 2. And that will give us 118 meter. So that's that about that. Let's take the second one now. At the 7th second of motion, that's from 6 to 7. Well, you can calculate for 6 seconds first and calculate for 7 seconds. Then you subtract the two of them. Well, I could just use our quick formula. The s will be equal to u plus at minus a over 2. Our t is 7. That will be s is equal to, our u is 0 plus a 4 times 7 now minus acceleration is 4 over 2. This will give us 4 times 7 is 28 minus 4 over 2, that is 2. And that will give us 26 meters. So that's that for this. So these are the following exercises we have, and the answers are given. So you can solve and then confirm with the answers.